Okay, I start from the beginning. So in last class we discussed about simple harmonic motion. So if we take a particle, it's moving from between these two distances. Let's say this is 2 meter, this minus 2 meter. Okay, and the particle is moving within this range, and we define simple harmonic motion as. Now you may get a question in your exam paper or your term paper. What is simple harmonic motion? Then you must write. Uh, it's a periodic motion. The term periodic should be there. It is a periodic motion. It is a periodic motion where its acceleration, the particle's acceleration, is directly proportional to its displacement. This term also must be there. The acceleration is directly proportional to displacement. So the displacement is measured from the midpoint. You have to mention that also. Okay. But this is not necessary. I mean, the main keywords is a periodic motion. Acceleration is directly proportional to the displacement. That term must be there. And also the acceleration always points towards the center or the equilibrium position, mean distance, mean displacement. Because if you consider the particle moving in simple harmonic motion, its mean displacement is 0, because here plus 2 and minus 2, if you take the average, it will be 0. Mean displacement is 0. Okay, so simple harmonic motion is a periodic motion where its acceleration is directly proportional to its displacement, and it is always pointing towards the acceleration always points towards the midpoint. Okay, so we can write in mathematically A is proportional to X. X is measured from the midpoint. Okay, A is proportional to X, and we write A is proportional to omega squared X. So this omega squared is equals to omega squared X. Omega squared is the proportionality constant. So then we can write. So this is the equation in magnitude. So this gives the relation between the magnitude of the acceleration and the displacement. But if you're writing this vector form, A is equals to minus omega squared X. So this is the mathematical formula for simple harmonic motion. Anywhere in the place universe, if a particle is going in such a motion, it is known as simple harmonic motion. So these kind of motions are there in for example, molecular vibrations and all. It is simple harmonic motion. Okay. So here, omega, the square root of this constant, which is omega, is also known as angular velocity or angular frequency. Angular velocity or angular frequency. Okay. So its units per second dimension t minus 1. Omega dimension is t minus 1. Since it has the same dimension of frequency, we call it as angular frequency. Okay. Right. And yeah, according to this formula, now if I consider the particle is here, then you can see again the acceleration pointing towards the center, displacement measured from here. So it is always opposite to the displacement. And if the particle is at midpoint, then x equals 0. If the particle at O, then x equals 0, then we get acceleration is equals to 0. So that means at the midpoint, net force acting on the particle is 0. In simple harmonic motion, it can be any simple harmonic motion. If the net force acting on the object at the midpoint is 0. So therefore, this is also known as equilibrium position. Equilibrium position. So midpoint. Also, we can say midpoint of the simple harmonic motion or equilibrium position. Okay. Right. And then we discuss one example where object is mass is attached to a spring. Okay, undergoing we show that it is undergoing a simple harmonic motion. For example, we have a object placed on a smooth plane by a massless spring. I take, let's say this is in equilibrium position. That means spring is under no compression or tension. So let's say this is the natural length. Then this is the equilibrium position. And then I give a small displacement. I pull this to a certain distance. Okay. This maximum distance I can mark it as capital A. So then now it's under compression. According to Hooke's law, there will be a restored force acting on this. So if I leave this, now I'm holding this. That means I apply a force F here, and then equal and opposite force, let's say dash, then equal and opposite force acting on it. But if I release this my hand, due to this force, what happens? This mass will move, accelerate. There will be unbalanced force when I release the hand. So this will accelerate, and as it is reaches the midpoint, the net force is zero. But due to the inertia, the mass is moving this side, right? Due to the inertia, momentum, again it will compress to the same displacement, and then it will undergo simple harmonic motion. So we showed that this actually going a simple harmonic motion using Hooke's law and Newton's second law. Okay, so we can write F equals ma. The force acting on it this is according to Hooke's law minus Fx equals minus kx. Force is minus kx and mass times acceleration. Therefore, a equals minus k over m times x. So therefore, here we can write minus omega squared x, right? Where omega is equals to omega squared is equals to k over m. So omega equals k over m square root. Okay. So here k is the spring constant. Spring constant. Okay, and m is the mass. Okay, so this gives the angular velocity. Now, if you know, if you derive the equation of simple harmonic motion, then you can find the angular velocity of the particle. Okay, so if you know the angular velocity, you can find the period time. T equals 2 pi over omega. Okay, or else, sorry. Yeah, T equals 2 pi over omega. Okay, the period time is equals to 2 pi over omega. Yes. This equation comes from, now I hope you have studied rotational motion. You can write if S equals, no, sine minus theta. Theta equals omega t. Okay, right. So S equals ut plus half at square. Likewise, theta equals omega t plus half alpha t square. Since it's removing at constant omega, acceleration is zero. So it's like S equals ut, object moving in a constant velocity. We have this. If object moving in a constant angular velocity, we have this formula. So theta equals to omega t. Okay. So here, T is the time taken for one period. So that means you take a particle particle, let's say t equals 0, and after one period, t equals capital T, the object will travel 360 degrees. That's in radian 2 5, right? So therefore, 2 5 equals to omega times t. T equals 2 5 over omega. Okay. If you want to note down, you can write this in the side note. But then again, we will be discussing about this later because we can consider a circular motion related to associated to simple harmonic motion. Any simple harmonic motion we can represent as a any simple harmonic motion we can represent as a circular motion. That part we will be probably doing in next week. Anyway, if you want, you can down. You can take a screenshot. All right. So this example we discussed in the last class, and then we got circuit graphs related to simple harmonic motion. Okay, first graph that we plot, so let's say 4, okay, the first graph that we plot is displacement versus time. How the displacement of the particle changing with time. Displacement and this time. Okay, so if I start to measure the time when the particle is here at t equals 0, so I'll draw this something like this. Here the mean position, this is minus a, and this is here. Plus a and minus a. So at t equals 0, if the particle is here, okay, and then if you go, the graph will be given by it's a waveform sinusoidal graph. You will get a sine graph. You will get a sine graph. This is how the wave move. The displacement varies with time because this formula is not there for physics, but right, the displacement is given by those who are doing combined maths. So you will be studying a sine omega. Sorry, this formula is there because I told you next week we will be talking about circular motion. So using that, we can show that the x is given by a sine omega t, where a is the displacement, omega angular frequency, t time. Okay, no need to write this formula now. We will be discussing that later. So you can see that displacement is a sine function. So you have a sine graph. If in case if you start the particle here, then the graph will change to like this. From here, if you start here, it will be like this. Okay, that means you just shift the axis to here. Okay, so then this function is a. It's equals a cos omega t. Okay, these things you will be discussing. We will be discussing later. But in physics syllabus, we only consider this scenario where we start the motion at the center point. But there might be a chance where they will ask, what if you start the time from here, then you have an extra phase sine phi plus omega t, then that extra phase is equals to phi over 2. Then if you put phi over 2, that formula change to cos omega t. We will be discussing more about this when we in the next week probably. All right. So this is the graph displacement changing with time and displacement, and then we got the graph of okay, the force versus displacement. Okay, so the force versus displacement. Okay. So here in this one, you can see the displacement positive is 0, negative, because here positive, 0, negative. So it's the displacement varying from 0 to plus A and then 0 minus A. So you can see this A, 0 in, right? And here force versus displacement X. So we know F is given by F is F equals minus Kx. Okay, F equals minus Kx. So we have force measured in Newton, this in meter, this plus A minus A. So it's a straight line because y equals minus mx. It's a straight line graph. Okay, and this maximum value corresponds to x equals to A. So the magnitude Ka here minus Ka. So we know what is K actually because omega squared is equals K over m. Omega equals K over m square root. Therefore K equals omega squared is equals K over m. So K equals m omega squared. So this will be actually equals to m omega squared A. And this minus m omega squared A. Okay. And the gradient of this graph gives gradient is equals to the spin constant A. Okay. Gradient is equals to the spring constant. Okay, so these are things that we discussed in our previous class, and then let's plot the variation of acceleration versus time. Or acceleration versus displacement here. So write down the variation of acceleration versus displacement. By the way, in this force versus time graph, you can see this force is actually the net force acting on the particle. So at the midpoint, it's 0, right? And at the here and here, it's maximum. Force will be maximum. So here, F equals 0, net F0. So F max. And here, minus F max. Okay. You can, along with this graph, you can put a summary. So at center, its net force acting on the particle is 0. That's why we call it as equilibrium position. So here the magnitudes will be maximum. Okay, and then acceleration was time graph. Sorry, acceleration was displacement. A meters per second square. P seconds. So the particle is moving from not px, it's meter. Acceleration was displacement variance. Okay. So here A and this is minus A. So the relationship between A and X that we know straightforward minus omega squared X, right? So Y equals minus mx type of graph. So again we have this type of graph y equals minus mx going through the origin. So when x equals 0, a will be 0. So you can see the midpoint, net force acting on the particle is 0, so therefore acceleration is 0, right? Okay, write down this, and the gradient is equals to omega square. In the previous graph, that is, force times displacement, you had right at the midpoint, at the center, the net force acting on the particle is 0. Therefore, it is called equilibrium position. Okay. Samatolita pihitima, equilibrium position. Okay, so here also you can write at the equilibrium position, acceleration is 0, and the magnitude of the acceleration is maximum at amplitudes. Okay, at amplitudes. So in last class, we wrote the note on what is frequency, what is period time, amplitude, those things, okay? So the frequency is number of cycles per second. Okay, and then period time, period time is the time taken for one oscillation. Now, for example, let's say I have a pendulum which is oscillates, it takes 0.2 seconds. So then this is the periodic time. Now, what is the frequency? Can you answer, Son? What is the frequency? I'm using my back cam, so I won't be able to see the screen. You guys have to talk. What is the frequency?
5.
Sorry?
5.
5. Yes, 5 hertz. Okay, frequency is given by 1 over capital T. So F equals 1 over 0.2 seconds. So 1 divided by 0.2 is 5 per second is hertz. That's clear now. For example, we take this timeline, 1 second, you divide into 1, 2, 3, 4, 5, so 0.2. It takes, the period time is 0.2, then being 1 second, it will make 1, 2, 3, 4, 5 oscillation, right? So therefore, the frequency is 5 hertz. Okay. All right. Draw this graph. Okay, so next, we'll get back to the spring system. Okay, we know if you have a spring, then it's vibrating. It's period time. We can now, if for example, if you want to find the period time, what you have to do is you have to write the equation of motion F equals ZA, and then you can get the minus kx equals mass times acceleration if equals ma. From this, we can get a equals minus k over m times x. So then we can find out that omega is equals to K over M squared, because it's really the omega squared. So then from that, we can write the period time T equals 2 pi over omega. Therefore, T equals, so you take the reciprocal of this 2 pi over M over K. So this gives the periodic time, right? Okay. And the frequency is simply F equals 2 pi F, 2 pi omega, because 1 over period times omega. Okay. So we have F equals, sorry, no, wait, 1 over T is F. So omega over 2 pi equals F. Omega equals 2 pi F, right? Or else frequency simply the reciprocal of this equals 1 over 2 pi times K over N square root gives the frequency. Okay. So quickly note down this again. Abhishan, we discussed about spring and its energy when we doing a work energy power, right? Did you attend that class? Okay. So can you tell me what is the elastic potential energy of the spring? What is the formula for elastic potential energy of a spring? You don't remember? Aisha, do you know the elastic potential energy of the spring? What is the elastic potential energy of the spring? No idea. Okay, so it is actually equals half kx squared, right? So we will derive that. So we have done this in work energy power, but then again I will do it. So when you have a spring, now let's consider attached to a mass, but mass is not necessary to this explanation, but fine. So this is in natural length, so the extension is 0, and then we give a small extension. So this is x. Okay, so then the work done, we can write equals force times displacement, but here the force is not constant. Force is proportional to x. So here F equals 0, and then when you apply the force, when the displacement increases, the force also increases. So then it's actually given by F equals kx according to the Hooke's law. Okay. That's obvious. Now, if you have a spring, it's easier to initially it's easier, but when you extend more and more, you have to apply larger and larger forces, right? Because force increases with the extension, right? So therefore, the force is not constant. So therefore, we have to take the average force, F average times displacement. So the average force I can write. So initially it is 0 plus now F over 2, we take the average, and then displacement is x. So then we have half fx, and at this instant f equals kx. So half into kx into x, we have half kx squared. So that is the work done. So in work energy principle, when you do work, okay. Now, for example, I take this, now it's here, and I'm going to do work. I lift this, I do work against gravity. When I do work on the object, the energy will store. So the work done on the object, it converts to energy. Now it has a higher gravitational potential energy. This work done is converted to gravitational potential energy. So likewise, this work done is converted to, so the work is done on the spring, so therefore it gains energy. Okay, so therefore the gained potential energy, elastic potential energy, it's a elastic potential energy. Elastic potential energy is equals to the work done. So E equals work done is half kx squared. Okay. We wrote this part earlier in the work energy power. In there, we discuss kinetic energy, gravitational potential, and elastic potential. So therefore, we have this already. But then again, you can write down this. Okay. So here, that is the elastic potential energy of a spring, half kx squared. Okay, quickly write this down. Let me know once you're done, finish. Abhi, you finished writing?
Yes, sir.
Okay, thank you. All right. Asha, if you're still writing, you can take a screenshot. All right, so now we know that the periodic time of a spring, how to find it, frequency, and then its elastic potential energy. So the elastic potential energy is given by half kx squared, where k is the spring constant, x is the displacement. P equals half kx squared. Okay, so write down the topic, instantaneous velocity, instantaneous velocity, instantaneous velocity of an object, of a particle of a particle moving in a simple harmonic motion. Instantaneous velocity of a particle moving in a simple harmonic motion. Okay. So let's take the thing which has a let's say this is 0. Okay, draw this. This is spin constant K. And here at the amplitude, we know the particle velocity will be 0. For example, if you take a pendulum, it goes to the amplitude and then instantaneously 0 and then come back. Okay. So here the velocity is 0. Okay. But here it has a velocity, it's moving in its direction v. So we are going to derive an equation for this v. Okay. Let's take this place at point P, and here is Q. Okay. Quickly draw this. So we need to consider the surfaces smooth and this massless field. Okay, so we are going to derive an expression for V. the instantaneous velocity, because this velocity is not constant. It is moving, changing with time and changing with distance. So here we are going to derive an expression where with related to displacement x. Okay. So for this, what we can do is we can consider the mechanical energy conservation principle or energy conservation principle. So considering energy conservation principle or using energy conservation principle. Using energy conservation principle, so we can write total energy at T is equals to total energy at Q. Total energy at Q equals total energy at T. Okay, so total energy at Q equals total energy at P. Okay, so here the energies we have kinetic energy half m p square plus potential energy half k square is equals total energy at P. Kinetic energy is 0. As the velocity is 0, the kinetic energy will be 0. This term 0 can simply write 0. Okay. Whereas if you write this, it will be straight. The velocity is 0. And the potential energy, it's elastic potential energy, half k x, x equals to a. The displacement is equals to a, k square. So then we will subject this to half intensity, half. So then we have m v squared is equals to this term 0 plus k a squared, and take this to the side minus k x squared. So then v squared is equals to k is common, I take out k times. So we have a squared minus h squared. So this m comes to this side. So k over m. Tell me what is k over m? This is equals to what?
Omega square.
Yes, that is equals to omega squared. V squared is equals to omega squared times a squared minus h squared. So this is the formula that I used to remember. Actually, we want to get the V now. So if I take V equals to omega times a squared minus x squared. So here we have to, so omega square root. So you can either box this formula or this formula, but I used to remember this one. V square equals omega square times v square minus a. Because I don't like to carry square roots. So I normally take this formula. But then again, here we are actually finding the velocity, not the velocity square. So for velocity, then you want, you can square this equation. So this gives how the velocity of the particle changes with displacement. So you can see here negative x squared. That means with x it decreases. When x increases, it decreases, right? So when x increases, it here decreases, and we can see when x equals to a, velocity will be 0. the amplitude velocity is 0, and when now this subtracting term, the velocity is maximum is minimum. The minimum x value is 0. So the maximum velocity we can do when x equals 0. We first write down. After that, we'll write this point. Since here we are taking the square root here, we have in some textbook you have plus or minus, right? This means when the particle is moving this side, you have plus velocity, moving this direction plus velocity, and moving this direction negative velocity, right? But if you are writing only the magnitude, then V equals omega times a square minus x. Okay, so after this, write the first point. The velocity of the particle decreases with displacement. The velocity of the particle decreases as displacement increases. Velocity of the particle decreases as the displacement increases. Okay, the second point. Second point, we can say okay. Second point, the velocity of the particle in simple harmonic motion, or velocity of the particle, is 0 at amplitude. Velocity of the particle is 0 at amplitudes. If both amplitude, if you put minus a or plus a, for both scenario, V will be 0. Because if you put minus a, so it's squared, you get a squared. So a squared minus a squared, 0. You get 0. And so we can write at x equals a. Or you can write at x equals plus or minus a. So you can put either plus a or minus a. We get v equals omega times a squared minus a squared. So v equals to 0. That's the second point. And the third point, so the maximum velocity. The maximum velocity. So the maximum velocity we can obtain by making this minimum. The V will be maximum when x is minimum. So the minimum x is equals to 0. So according to
Excuse me,
So
sir.
the formula, sorry,
So can you say the point again?
uh, the third point.
Yeah, sir.
Okay, I just third point. I just gave a like a subtopic, the maximum velocity. Okay, and incomplete. Okay, just the maximum velocity, and I have put a semicolon. Okay, so according to the formula, which is V equals V squared equals omega squared A squared minus H squared. V is maximum. V is maximum when x goes to minimum value, right? When V is maximum, x will, sorry, that is say when x goes to minimum, x equals to x min, we have V equals to V max. Okay. When x gets the minimum, when x is minimum, V will be maximum. So we know x min is 0. Therefore, V squared is equals to omega squared times A squared minus 0. So we get V squared equals A squared omega squared. So you take the square root both sides, V equals plus or minus A omega. You know how this plus or minus comes, right? Because there are two solutions. That's oral mathematics. So you take V squared, take this term to the other side, you get A squared omega squared equals 0. So it's a difference between two squares. So I can write this as A omega squared. So V minus A omega times V plus A omega equals 0. So a product is equals to 0 means either this term is equal to 0 or this one is equal to 0. V minus A omega equals 0 or V plus A omega equals 0. So we get V equals A omega or V equals minus A omega. Right? So therefore V equals plus or minus A omega. Right? So that is the maximum velocity. Uh, this is a oral max. I hope you don't need it. If you want, you can take a screenshot. Yes. Okay. So here V square equals A square times omega square. If you take the square root, you have to put plus or minus. Okay, so V equals plus A omega. That means we have two solutions, right? So if you take this particle moving in a simple harmonic motion, here plus A minus A, when the particle is here, if it's moving this side, we have A omega. Okay. But if the particle moving this side, we have minus A omega. Okay. So we have two solutions. One is A omega, one is minus omega. So this minus means, now if you consider this side is positive, then minus is in opposite direction. So we have two solutions, right? Okay. So this is the maximum. So here we put V max, max. Okay. The maximum velocity is equals to the magnitude of the maximum velocity is given by A omega. So the magnitude is A omega. Okay. Write down this question. Replace someone more. Okay, write down this question. An object of mass, an object of mass, an object of mass 2 kilogram, an object of mass 2 kilogram is placed on a smooth horizontal surface, is placed on a smooth horizontal surface and is attached, and it is attached to a horizontal, to a massless, to a massless horizontal spring, to a massless horizontal spring of spring constant, of spring constant 0.5 Newton per meter. 0.5 Newton per meter. Mass of 4 kilogram. Object of mass 4 kilogram is placed on a smooth horizontal surface and it is attached to a spring of massless horizontal spring. The spring constant K, and the other end of the spring is attached to a vertical wall, and the other end of the spring is attached to a vertical wall. First up, initially the mass and the spring. Initially the mass and the spring is at equilibrium position, is at equilibrium position, and given a displacement of 1 meter, and given a displacement of 1 meter to the object, and released from rest, and released from rest, and released from rest. Uh, 2 kilogram and 0.5 Newton per meter. Okay, Roman number 1. Show that particle undergoes a simple harmonic motion. Show that particle undergoes simple harmonic motion. Roman number 2. Find the frequency of the object. Find the frequency. Roman number 3. find the maximum acceleration. Find the maximum acceleration. Find the maximum acceleration within brackets a max. Find the frequency within brackets simple f. Find the maximum acceleration. Roman number 4. Find the maximum velocity Vmax. Find the maximum velocity. Roman number 5. Find the velocity of the particle. Find the velocity of the particle at displacement of 0.5 meters. At a displacement of 0.5 meters. Okay, you can start now. So to show simple harmonic motion, you have to show that A equals minus omega squared x. Okay, that we wrote in the note as well. Okay, so at any given instant, if you consider the particle, so we can apply F equals ma. So acceleration is displacement and like using F equals ma. So in this direction, F force at harmonic equals mass times acceleration. So F equals k times x. So I'm using this equation this direction, but displacement is this direction. X equals ma. Okay. So then we have minus kx equals mu. So therefore a equals minus k over m x. So therefore motion is simple harmonic. Okay. So then find f, find the maximum acceleration, find maximum velocity, and find the velocity of the particle at 0.5 meter. Take for this question, take 5 equals 3. Aisha, you finish the Roman number 2? Are you done with the question? I would really appreciate this Katala Kiamel. Are you done with this Roman number 2?
Yes, sir.
Okay, thank you. Can you share your answer? What about Abhi? Are you done with this?
Yes, sir.
Sorry, I didn't hear you.
Yes, sir. I'm done with the answer.
Okay, then tell me, Abhi, what is the answer for this?
0.083 hertz.
0.0.
833 hertz.
Sorry, can you repeat again?
0.083 hertz.
0.83 seconds. This is your answer.
Sir, we have to
Uh,
find frequency, right?
yeah, frequency. I'm asking here to find the frequency. No, second question you wrote this. What about Aish? What do you
Yeah.
got? Aisha, what's your answer? Aisha. No, I didn't hear you. Can you speak now? I think you talk while your speaker is muted. No. Okay, your mic is unmuted, but that green color it's not visible here because the your speaker doesn't receive the sound. I mean, your mic don't receive the sound. I think still it's like that one. You're connected. You can text me, Aisha. You are connected from mobile device or the laptop. Okay. Don't you have any external mic like from a speaker or anything? Or there is a key in laptop. I think that key is like F1, F7 or something. It modes. Then we won't get any sound. Sure. Anyway, what's the answer? The problem is your Zoom is not muted. Okay, it's fine, but your laptop audio is muted. You had to unmute the laptop audio. In your laptop keys that F1, F2, F3, there is icon something like this. You have to click that. Anyway, so let's make the answer out. 0.083. Okay, so you both get 0.083. This should be per second hertz. Okay, let me check. So first we want to find the angular frequency omega. Omega equals k over n square root. Omega equals k over n square root. Okay, so yeah. Then we have omega is equals to k is that's k 0.5 and mass is 2. So square root. So omega equals is 0.25 square root. So therefore omega equals 0.5, right, per second. So then the frequency f equals 25 uh, uh, omega equals 25 f, f equals omega over 25. F equals omega over 25. So therefore f equals omega is 0.5 divided by 2 into 3. So we have 0.5 divided by 6. 0.5 divided by 6, I think it's no. Okay, so 0.083. That's, I think it will be 0.83333. Will come. 0.08 into 6 into 5. Yeah. So the answer is 0.083. Okay, and then find A max, V max, and the velocity at 0.5. Okay, what is the maximum acceleration? You can text your answer. Okay, to find A max, minus, so we just consider only the quantitative. Omega square, its maximum. A is maximum when x is maximum, maximum x is A. So we have omega is 0.5, 0.5 square times A is 1. So 0.25 meters per second square. Okay, and V max. So maximum velocity we know it's a omega. So 1 times omega is 0.5, 0.5 meters per second. By the way, by looking at this two equation, you can get a relation between V max and A maximum. Right? If you divide these two equations, here A omega cancel. So we get A max is equals to, or as omega times A is V max. So omega times V max. So this formula is not there in the syllabus, but in MCQs and all you can write. Okay. So A max equals omega times V max. Okay. By combining these two equations, this you must know. This you can deduce from these two. A max is equals to omega times V max. Alright. And velocity at 0.5 meter. Fine. Okay, I got the answer from Abhushan. What about Aisha? Are you finished with this last question? Okay, I'll give you a couple of minutes. Try to give it. Okay, got the answer? Okay, what is the answer? Okay, so let's check. So Abhishani's answer 0.43, Aisha's answer 0.25. Here we found the A max is 0.5. So anyway, it has to be smaller than 0.5 meters per second. So both are acceptable. And so to find the Vmax, velocity at any instant, we have this formula V squared is equals to omega squared, A squared minus A squared. So V squared is equals to omega. The value of omega is, we found it 0.5, no? 0.5 squared. A is 1, squared is 1, minus x is 0.5. So 0.5 squared we have. So V squared is equals to, we square this. I'm not going to square this because then I have to take the square root again. So I keep it as square. 1 squared is 1 minus 0.5 squared is 1 minus 0.25. Okay. 0.5 squared is 0.25. So V squared is equals to 0.5 squared times. So this is 1 minus 0.25, 0.75. So taking the square root of 0.75 to so therefore I write like this, 0.5 square 3 into 0.25. So 0, okay. So then we have V squared is equals to 0.5 squared times 0.25 is actually 0.5 squared again. 0.5 squared times 3. Now I can take the square root both sides. V equals, here we get plus or minus, we only consider the magnitude. Because there are two solutions. We get the same values. Yeah, you take here 0.5 meter, here 0.5 meter, will have the same velocity. So here, if you take the square root, this will be 0.5, and then this 0.5 times root 3. So V equals 0.25 times square root of 3 is 1.732. We take for the first decimal place 1.7. So then I want to take this answer, multiplying this hard for me. So 0.25 I can take it as 1.104. 1.7 divided by 4. 4 into 4, 16 remains 1. So we are looking at this here. So for 10, we have 2. So 4 we have 16 remains 1. For 10, how many 4s are there? 2, 8 remains 2. For 20, we have 5. So V equals 0.425 meters per second. That is approximately, otherwise here you get a value more than this. I think 0.43 will come because 1 root 3 is 1.7 blah 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 blah. So I have approximate to 1.7, that's why I'm getting a lower value. It can be something 0.43. Okay. So that is the answer. Good. Okay, so the next we will plot the graph of V versus X. Sorry. Anyone over there? All right. Okay.
No, sir.
Okay, so I heard some voice. All right. let's plot the graph how v versus. So write the topic variation of velocity with displacement. Variation of velocity with displacement. We have this formula v square equals to omega square a square minus x square. So using this formula, you have to plot the graph. So I'll explain you. I'll expand this. So we have v squared is equals to omega squared a squared minus omega squared x squared. So here we have the variable and this is a constant. Omega is constant, right? Because the spring constant කියනකොට වචනෙන්ම තියෙනවානේ. The word itself says it's a spring constant. So omega equals k over m. So k is constant, mass of the particle is constant, or the mass of the object is constant. Therefore, this is constant, amplitude is constant. So this is a constant times here we get minus omega squared x squared. Okay. So what I'm going to do is I'll rearrange this formula. So here v squared, I take this to this side. Omega squared x squared is equals to omega squared a squared. Okay. Now I'm going to divide the whole equation by omega squared a squared. Dividing by omega squared a squared. So we get v squared over a squared omega squared plus x squared over, when you divide by this, omega cancels off, we get a squared equals 1. So it's nice. See, v velocity squared, a omega is also a velocity, actually the maximum velocity, right? It's the maximum velocity, right? Vmax, we wrote earlier, Vmax is equals to a omega. So this is the maximum velocity, this maximum displacement, right? And it's equals to 1. So this is dimensionless. Velocity square divided by velocity square, dimensionless. Displacement square divided by displacement square, dimensionless. So here dimensionless. Okay. So then I write this v square. This is the variable over a omega square plus x squared over a square is equals to 1. So the variable, its maximum value square, this square divided by this square divided by this square is equals to 1. Okay, so what is this formula? What is this equation? So this is the equation of ellipse. Equation of ellipse. We can call elliptical curve. Elliptical curve. Okay. So we know the equation of ellipse is x squared over a squared plus y squared over b squared is equals to 1. So this is the elliptical curve. By the way, we don't have this equation in A-level max syllabus or A-level physics syllabus, but as a general knowledge, you should just know this. This is the elliptical curve. And by the way, this derivation also not there in the syllabus, but I'm doing that so that you will know how this curve actually comes. Otherwise, I can give make a velocity, time versus displacement graphical I don't like that way of physics. Okay, physics means everything based on the principles, on the foundations. So what are step by step learning. Now, for example, when I read some books like quantum physics or any books and all related to physics and all, so the author sometimes read the derivation of this formula is omitted for the layman's convenient. You can කියවන කෙනාට පහසු වෙන විදිහින් වෙන්න ඕනේ හින්දා proof එක derivation එක omit කරලා තියෙන්නේ කියලා. If such author's book I don't read take because it really annoying me. Okay, because maths එක තිබ්බා තමයි we understand මේකින්ද තමයි මේක වෙන්නේ. It's based on logic. මේකින්ද තමයි මේක. Because now for example one formula, for example p equals mc. This one formula have the information of thousands of pages. A 1,000-page paragraph කියනකොට වඩා lazy මෙන්න මේක තිබ්බනම්. So how many this thing are there? The force is directly proportional to the mass, force is directly proportional to acceleration, acceleration is inversely proportional to the mass, and then if you increase the acceleration, force also increase. If you double the acceleration, force will be double. If you triple the mass, force will be triple. If you reduce the acceleration by half, force will be half, and like that. Okay. So this part, what I'm deriving, this part is not there in the syllabus. But again, you write down so your note will be elegant and beautiful. Okay. So then we have now if you take this vertical curve, okay, so we can draw. So this is, let's say, y-axis. This is x-axis. So x squared plus y squared equals 1 over. So this elliptical curve we draw like this ellipse. So it's a ellipse. It has to be symmetric. So here let's say the y value is plus b and then minus b. X is a and minus a. A and then same distance minus a. So it's an ellipse. Okay. Since you all are very bright, brilliant kids, I'll ask you one small question. What would happen if a equals to b? If the value a equals b, what do you get? Just look at this picture and imagine what would happen if a equals to b. What do you get? Okay, I got the correct answer from Aisha. Good. Abhirshani? Abhirshani should say you are doing combined maths now. Just guess, it's okay to இல்ல பரவாயில்ல, just guess பண்ணுங்க பாருங்க. Okay, all right. So the answer we have squared over a squared plus y squared over b squared is equals to 1. So if a and b are equal, in the form equal, and what you get? A circle. So let's say a equals to b equals, let's say, r. So then I write x squared over r squared plus y squared over r squared is equals to 1. So we have x squared plus y squared equals r squared, which is the equation of circle. This you must know, Abhishani, because you have entire chapter, coordinate geometry, circles, straight line, you have one entire chapter, circles, you have entire chapter. So you will first learn that circles, this is a circle from the origin, is given by this formula. Circle from any other point have different equation. You will be learning more about that in PO paper, the coordinate geometry. You have entire unit circles dedicated for circles. Okay. So here you get the equation of circle, because if you draw a circle from here, you can consider any point on the circle, the general coordinates as x comma y. So this x comma y satisfies this equation that x squared plus y squared is equals to the radius squared r squared. R is the radius of the circle. Okay, using Pythagoras theorem, we have x squared plus y squared equals r squared. So it gives the equation of circle, and it is not there in the physics. But it's nice to learn. We are science. Don't really need to learn for the exam, but learn for the knowledge. If you have a greater purpose of learning, studying, then you want stress when you are studying. When I'm exam படிக்கிறேன்டா exam இவ்வளவு படிக்கணுமேன்ற stress ஆகும். அதே இல்லாம if you have greater purpose, I want to become a scientist, I want to become an astronaut, I want to do this and give society to this. So you will enjoy learning these things. Okay. Anyway, so here, so now we will apply this elliptical curve for our this one. Okay. So here we have the velocity versus displacement graph. Velocity measuring meters per second, and displacement is measured in meters. So we know the displacement of the particle is bounded between plus a and minus a. So here, elliptical curve. Okay. And v, it's bounded between plus a omega, the maximum, a omega, and here the, because we know v is plus or minus a omega v max. So then this negative means it's moving in the opposite direction. There, the maximum value is minus a omega. So you have a ellipse. Okay. Here you should have a curved. Okay. Here also curved here. If you draw like this, it will be wrong. If you draw like this, here can't. This is okay. This side is correct, but here also it has to be a curve. Curve should be there. Okay. Here a omega minus a omega. Here plus a, and this is minus a. Okay. So our topic is velocity, the variation of velocity versus displacement in the topic கொடுத்த syllabus in the graph method. You should only know about this graph. This is must. All this part is just for fun. We are learning. Okay. These things are not there in syllabus. But this graph you must know. Okay. This is must. Okay. Plot this graph. So elliptical shape. And one additional detail I'll tell you, apart from the syllabus. You know, if you take a circle, it has a one center, but ellipse has two centers. Okay. And ellipse have two center points. Now, for example, let's say a ball, it's a table or something. Right? If you take a circle, no, let's no, okay. So, for a circle, you have one center, but ellipse, you have two center. Now, in our A-level physics and all, we study the Earth is going around the sun in a circular motion. Okay. So this is sun and Earth is here. But actually, it's going in an elliptical. But in our syllabus, you should know it's a circular path. The sun is here, and the Earth is going in an elliptical. Okay. So I'll give you one homework. It's a question. Draw the variation of momentum within brackets t versus displacement of a particle in simple harmonic motion. of a particle in simple harmonic motion. I'll give you a small hint. To answer to this question, you have to understand the velocity, this graph. You have to use this knowledge, and you should know the relation between velocity and the momentum. Okay, so that's for the homework, and we will start in the next class about kinetic energy and potential energy and total energy of particle moving in a simple harmonic motion. After that, we will be discussing the circular motion related to simple harmonic motion. All right, kiddos. So that's all for today. Do you have any questions based on regarding today's lesson? So today night no class. So that class only I'm taking now. All right. So have a nice day. See you.